Chapter 29, Braking Fundamentals, Video 8, Air Disc Brake. So some of the advantages to using an air disc brake, more consistent braking side to side, front to back, just a more consistent braking effort that we get with an air disc brake has to do with its cooling abilities. On the drum brake, we had large, wide shoes in there that covered almost the entire surface of the drum. Lots of surface area, but now we've got the ability to dissipate that heat out. We don't have much opportunity for the air to work on that surface in the drum because it is all taken up with the shoes creating the friction. So an air disc brake, it is just the opposite. We've got very little amount of area is being used to create the friction, and then the rest of that surface is cooling as it's rotating around. And then it's got a built-in, like a cooling fan effect of the rotor that allows the air to pass through that rotor and cool it very quickly. So brake fade that we would get from the disc brakes is a lot lower than we do with drums. Consistent forces and shorter service time is definitely one of the advantages. So disc brakes use a rotating disc instead of the big drum on a drum brake system. We've got a caliper or a floating caliper that causes the brake pads to clamp around or try and squeeze that brake rotor, create the friction. Air chamber located built into the slider or the caliper. The release and all that of the and the automatic slack adjuster is built into the caliper of the disc brake. So the effect here is, again, the cutaway. We've got air pressure coming in, working on the surface area of that piston, pushing through, and now we've got, here's the actuator. As this is pushing forward this way, would cause the adjuster to be pushed into the brake shoe, and we've got, again, automatic slack adjuster built into the brake caliper itself. So if you want to think of like a C-clamp where we are applying pressure on one part of that C, and then just the shape of the caliper or the C-clamp comes around and would start to pull in the opposite side, and once that has taken up all the clearance, any more pressure that's put on this the adjuster here that is applying pushing the brake pads into the rotor is going to increase the braking force. A little bit of the takeaway here of the disc here, it has got vanes built into the rotor. Here we can see them coming through the center here and around that rotor too. And then if we were to look inside of that, we would have sometimes a straight vein coming through there, creating little tunnels inside that rotor that draw air in and through. So we are cooling the rotor by forcing air to go through the center of it, transfers that heat to the air, and then now it's spun and sent out into the atmosphere as the rotor's turning. Caliper on the outside, brake chamber here, so we would be pushing in on the actuator here. Again, forcing this shoe into the rotor by the shape of the brake caliper. The opposite side would pull in, and now we've got the rotor being pinched or squeezed between the two brake pads, creating the friction, creating the heat, and then getting rid of that heat very effectively. And then as you can see, we've got a nice open space here to be able to remove and replace these friction materials